to differentiate rational functions or other formulas that look like fractions, you have to use something called the quotient rule. And I would rate this as the second most ugliest formula right after the quadratic formula. I think the quadratic formula is the ugliest thing of all, and this is right after it. It's you differentiate the first times the second minus, remember how in the product rule we had plus, and now this is minus f of x times g prime of x divided by the denominator squared. And once again, quotient rule, this word rule is not in the sense that it's a convenient thing. This is the rule in the sense that if you don't obey it, you get punished. So if you have a fraction and you do not use the quotient rule, then you're going to end up with the wrong answer. Okay. So let me dig into that just a little bit more. So let's say you have x squared over x, and you were told to differentiate this. Now the wrong way is, let's say you did this in the wrong way, and let's say you didn't know the quotient rule, and you just did like, derivative of x squared is 2x, derivative of x is 1, so is it this? Well, this would be wrong. It's completely wrong, okay? This would be like not obeying the rule, which is the quotient rule. The quotient rule says you should be doing x squared prime, differentiate the top, times the bottom. So first thing first, second, and then minus. Leave the first thing that which you already differentiated at once, and now deal with the second one that you did not differentiate. Okay. In all these derivative rules, everybody gets a turn. So if you have one big function and when you differentiate it, then when you differentiate by little parts, everybody gets a turn. So x squared gets to be differentiated at some point, x gets to be differentiated at some point, and then you divide by the denominator squared. Okay, so what is this? X squared prime is 2x times x prime is 1 over x squared, so that's equal to 2x squared minus x squared over x squared. 2x squared minus x squared, that's just x squared, right? So it's x squared over x squared, which is 1. Now, actually, this is a ridiculous case when you use the quotient rule, because there's a way to simplify. So the only time that you can avoid having to use the quotient rule is if you can simplify it so that it doesn't look like a fraction. So here's what I mean by that. So you have x squared divided by x, which is x, right? So this is same thing as x. Therefore, the above is same thing as just x prime, which is this 1, right? So that was a lot simpler because we were able to avoid having to use the quotient rule by making it into a non-fraction. But in most cases, you will end up having to use the quotient rule because there's no way around it. So let's do some more examples. Here's a simple example. 3x minus 5 over 2x plus 1 prime. Well, this is a fraction. There's no way around it. You cannot do other algebraic simplification to make it into a non-fraction. It is a fraction. I mean, if you really insist, you can do something like this. You can rewrite 3x minus 5 over 2x plus 1 as like 3 over 2 plus 2x plus 1. What's that? I don't know. You can have some number in here. I don't even know. But it just gets really complicated really quickly. Okay, so here you're stuck with the quotient rule. although it's a disgusting rule, you still have to use it. You have 3x minus 5, differentiate the first one first. Second one has to wait its turn. Instead of a plus like the product rule, this time it's minus because it's the quotient rule. 3x minus 5, you already got your turn. Now 2x plus 1 has to be differentiated. Divided by 2x plus 1 squared. 3x prime is 3. 5 prime, that's just the constant, so it's 0. And then 3x minus 5. 2x prime is 2. 1 prime is 0. Divided by 2x plus 1 squared. You could expand this, but if you expand this, it becomes more ugly. So I'll just treat this as the simplified one. So let's try to simplify. 3 times 2x plus 1, that's 6x plus 3. Okay. Now here is the single most source of error when people use the quotient rule. Is this minus? And many people forget the parentheses, okay? So if you forget the parentheses in this calculation, you will end up with a sign error, okay? So make sure that when I multiply 2 to the other ones, keep the parentheses intact. 2 times 3x, that's 6x. Negative 5 times 2, that's negative 10. Divided by 2x plus 1 squared. And finally, what's that? That's 3, okay, 6x will cancel, right? So these two will cancel because it's minus. And then minus minus is plus, so it's 3 plus 10, which is 13 over 2x plus 1 squared, okay? So that's how you use the quotient rule. All right, let's do another example. Here's one with, say, exponential function and quotient rule. So let's say you have x squared minus 5 over 5 e to the x plus 7 prime. Okay. All right, you have x squared minus 5. The first guy gets his turn. 5 e to the x plus 7. The second guy has to wait. Minus x squared minus 5. Now it's the second guy's turn to be differentiated. And you have 5 e to the x plus 7 squared. The denominator has to be squared. Okay, x squared differentiates to 2x. 5 prime is 0, so we just need this. Minus x squared minus 5. And then, oh, I forgot to put the derivative sign. This has to be differentiated. E to the x differentiates to e to the x. How beautiful, right? So 5 e to the x. And then 7 is a constant, so if you differentiate, that's 0. And you have 5 e to the x plus 7 squared. And you should multiply them out. Be careful with the minus signs. 2x times 5, that's 10. Right? So it's 10x e to the x. 2x times 7, that's 14x. Negative x squared times 5, that's negative 5x squared. Negative, negative, so that's positive 25. Yeah, so you could avoid having to write down the parentheses if you are super careful about these signs, okay? But treat this sign problem as a serious business because that's like the #1 place many people make mistakes. Okay, so I don't see any like terms, so I would consider this as the most simplified one. I mean, if you really want to simplify, I guess e to the x can be put together by writing it as 10x plus 25 e to the x. And then usually you put the higher order first, so minus 5x squared comes first, and then plus 14x over 5e to the x plus 7 squared. Okay. Now, last one I want to do, let's do something with the a to the x, because we haven't done that much. Okay. So let's try 2 to the x plus 3 divided by square root of x prime. Okay, so the first guy gets his turn to get differentiated. Yeah. I keep thinking about haircut, like getting haircuts, people lining up in the mess deck, right? Yeah. 2 to the x plus 3, then square root of x, and you differentiate here, and then square root of x squared, denominator squared. 2 to the x, according to this right here, is 2 to the x and then ln of 2, right, times square root of x, and then 2 to the x plus 3, differentiate square root of x, that's 1 over 2 radical x, and divided by square root of x squared, which is just x. And see, you have fraction inside the fraction, so in that case you should simplify top and bottom by multiplying by square root of x, or 2 radical x, yeah, so that you don't have a fraction. That's like the polite thing to do. So if you have a fraction inside fraction, get rid of the denominators by multiplying the denominator top and bottom. Right? So in the denominator it's 2x times square root of x, and this is, it's really crazy, but it's like 2 to the x square root of x times ln of 2. I just switched these around because if you don't write the parentheses, this looks like ln of 2 times radical x, and certainly that's not what I want, so I put the square root of x here. And then, look, 2 radical x got cancelled. Oh, you know what? It's 2 radical x times square root of x, right? So that's actually 2 times just x. I forgot that we multiplied by square root of x. So let's erase this a little bit. Let's think about this again. So what is this? Square root of x times 2 radical x. What's that? That's 2 times square root of x squared. So that's just 2x, right? So when you have square root of x multiplied by 2 radical x, you get 2x. So you actually end up with 2x times 2 to the x ln of 2. That's the first term, right? And then 2 radical x cancels away, leaving you with 2 to the x. And then because you're going to get rid of the parentheses, this will be minus 3. Okay, so as ugly as it is, this is the best you can simplify.